Okay, Assalamualaikum everyone. So we go to the chapter 3, which is estimation. So what is estimation? Okay, let's take a look at the example. Let's say, okay, we have a population of, okay, 7,000, okay, IIUM students. And as a researcher, I'm interested to know the amount spent, okay, on food, okay, per month among IIUM students. Okay, my question is, did you think that it is possible that all 7,000 students will take part, okay, in this survey? Okay, normally, okay, in fact, normally, okay, not all 7,000 will join the survey due to the some constraint, due to the unavailability. So what we will do as researcher is to take only few sample from this 7,000. Maybe we take the survey for only 4,000. Okay, so this is what we call as sample from the entire, okay, 7,000 of IIUM student, entire students. We take only few sample. This is what we call as, okay, sample. We take only few students to join the survey. Okay, so we have a different kuliah, right? Maybe we sort this student according to the kuliah. Let's say we have KOE, GAID, okay, and then we have KIR, KHS. Okay, so we have all, okay, 4,000 students, means that we have 4,000 data. And from this 4,000 data, okay, we take an average. For example, sample average or mean from this 4,000, okay, or SPA. So we get the example, let's say RM 350 ringgit, okay, this average per month spent on food among IIUM student. So this sample mean or average is estimator, what we call as estimator. So it will be an estimator to population, because it is impossible to have all 7,000 students to take part in the survey. So we only take a few sample. This is what we call as estimation process. We take only few sample and we take an average. So from the sample average, okay, it will be a representative to the population mean. This is what we call as estimation process. And you have to take note, okay, the estimator not only the mean lah, it can be also in terms of standard deviation, variance, okay. So not only mean, we also can calculate or approximate, okay, the standard deviation and also the variance. And this 350, this is what we call as point estimate, which is an estimator. Doesn't matter lah whether it's mean or standard deviation or variance, okay. We express all this estimator in terms of single number. Okay. But in statistics, normally we are interested to put in a range. Instead of 350 exactly on average students spend on food, okay, we are very confident that exactly 350, we put it in terms of interval. Maybe RM 350, okay, plus minus 50, okay, on average. So this is what we call as interval estimate, or we put in this interval in the range. Okay, you have the population, okay, mean, okay, or true mean here, okay, true mean, and we put in average. We have the lower value, okay, lower value, and also the upper value. So this is what we are always interested in this statistic, in form of range. Okay, we want to have a range of estimation. This is also what we call as a confidence interval. We put the means or the variance or the standard deviation in terms of range instead of a single number. Okay, you have to take note on these two, point estimate and interval estimate. Point estimate, we put anything that we have, whether it's mean or standard deviation or variance in terms of single number. Meanwhile, the interval we put in a range. We have the lower value and the upper value that represent the parameter, whether it's mean, standard deviation or variance. Okay, so what are the properties of good estimator? Firstly, it must be unbiased. What does it mean? It means that, if you want to take a survey, for example, this survey, amount spent on the food, you cannot take only the rich student. Only the rich student. If you take only the rich student, the total amount spent must be more higher. For example, instead of 350, RM 1000 per month. So it is unbiased. So you have to include all background, all demographic in order to ensure that the value is close in some sense. You cannot take only the rich background or poor background. You must include all the background, all demographic, to make sure that it is unbiased. Okay, so for the second estimator, good estimator is to have a consistent estimator and also efficient estimator. So what does it mean? It means that, if let's say you want to increase the sample size from this 4,000, you increase to 6,000. Even if you increase the sample size, the value of average 350 here is not too vary. Maybe you got 400 per month. It's not too far lah from this mean. You couldn't get, for example, RM 2,000. From this 350, you got 2,000. It's too far from the true value. So this is not efficient. You must get close value even you increase the number of sample size. Also, let's say you want to repeat this survey to the next semester. Even that you conduct at different time, you will get not too far sample value. So this is what we call as efficient and consistent estimator, not too far from the true value that you get. After you got the variance or mean or standard deviation, you can calculate the standard error given by this formula. Sigma divided by square root of n. Sigma is population, standard deviation, S is sample, standard deviation. Depend on the question whether you want to use population or standard deviation given by in the question lah. Whether it give you this population or sample standard deviation, divide by square root of n. S is a number of sample or sample size. So I want you to take note that in chapter 1 and 2, we use the general notation, whereby for example, for mean we use mu, standard deviation we use sigma, and variance we use sigma square. We use the same notation. But in chapter 3, onwards, you have to take note that you need to differentiate between these two, sample and population. Population refer to the entire group, entire pupil. So the sample, the mean is given by S bar. For the population is given by mu, the mean. The standard deviation for the sample is given by S. For population is given by sigma. For variance, for sample is given by S square. For population is given by sigma square. So you have to take note on these two difference, because it will give you different meaning. So you need to know how to differentiate between these two notations. Now we go to example 1. An article in the Journal of Heat and Mass Transfer describes a new method of measuring the thermal conductivity of Amco iron. Using a temperature of 100 Fahrenheit and power input of 550 watts, the following 10 measurements of thermal conductivity were obtained. So basically, you have number of sample, number of sample or sample size is 10 lah. 10 is n. So you have 10 data of thermal conductivity. So A, find the point estimate of the mean thermal conductivity. Point estimate or estimator can be either standard deviation, variance or mean. But in this question, it asks you to find point estimate of the mean. So mean lah, no need to find the standard deviation, point estimate of standard deviation or variance. So just focus on the mean. Okay, so here I want to ask you, mean here refer to as bar or mu? Okay, as you notice here, we are dealing with 10 sample. So here we use as bar. Okay, sample mean, which is equal to summation of x, where you have to sum up all the 10 data here and then you divide by number of sample. This is how you calculate manually. So you will get 419.24 divided by 10. Okay, but I want you to be familiar how to use calculator in order to get the mean, standard deviation and variance, because in the calculator you have this function in order to get the mean, standard deviation and variance automatically. Just you put the data, okay, just you press and input this all 10 data, okay, inside the calculator, then it will give you the value of mean, standard deviation and variance. And if you use this calculator, okay, it will give you directly lah. So as bar here, no need to calculate manually. So it will give you 41.924. And the function here depend on the model of calculator. How you press, okay, depend of the model of the calculator. So try to Google how to find the mean, standard deviation and variance using the scientific calculator. In the Google there are many model. They show you the tutorial how to find this one. Okay, so for B, find the standard error of the sample mean. Standard error given by sigma bar x. So we are dealing with sample, right? So we use S for the standard deviation of the sample, divide by square root of n. So S here, okay, you need to use the calculator. You just put this 10 data inside the calculator, then you get the S here equals to 0.284 divided by square root of n, which is 10, which is 10 here, right? So 10 here, square root of 10. So the answer here is 0.0898. So this is very important to know how to calculate or to find the mean, standard deviation and variance using the calculator. Let's say you have 20 or 30 data. Do you want to calculate manually? So the best way is to use the calculator. Okay, I think that's all for how to find the point estimation and standard error using the calculator lah, I would say. So I think that's all. Very easy and straightforward.